Hi, it's Professor Adam. Let's talk about worked examples of empirical and molecular formulas, making use of percent compositions and the relative masses of each element in our compound. Our first problem concerns a compound which is 40% carbon, 6.71% hydrogen, and 53.29% oxygen by mass. And we're asked to find the empirical formula first, followed by the molecular formula if the molecular mass is 150.13 grams per mole. So, since we're given the percent composition, we can just turn this into grams if our compound, if we have 100 grams of our compound. So that would mean that we would have 40 grams of carbon, we would have 6.71 grams of hydrogen, and we would have 53.29 grams of oxygen in our compound. We then want to get the number of moles of each one of these, so we would go for 1 mole of carbon has the mass of 12.01 grams, which would give us 3.331 moles. Then we would do the same thing for hydrogen, which is 1 mole of hydrogen is equal to 1.008 grams, which would give us a number of moles as being 6.657 moles. And then we would do the same for oxygen, where 1 mole of oxygen is 16 grams, which would give us 3.331 moles. The next thing is to divide each one of these by the smallest number of moles, which is 3.331. So divide by 3.331, divide by 3.331, and then divide by 3.331 again. And so that gives us gives us a value of 1 for carbon, gives us a value of 2 for hydrogen, and gives us a value of 1 for oxygen. And so these are going to be our subscripts in our empirical formula, which gives us an empirical formula of CH2O. And so this is our empirical formula right here. We can then use this to find our molecular formula. So our empirical formula we worked out on the previous slide was CH2O. We can then take this and determine our molecular formula. The first step of this is to find out what the molar mass of our empirical formula will be. So we have 1 carbon, 12.01, plus 2 hydrogens, which is 1.008, and then we have 1 oxygen, which is 16.0. So that would give us a molar mass of our empirical formula as being 30.026 grams. We can then take this, and we know that a molar mass of our compound is 150.13 grams, and we then divide the larger number by the smaller number. So divide this number by the 30.026 grams, and the quotient of this will then give us our multiplier for our empirical formula. So this gives us a value of approximately 5. We always round up to a whole number. And so we use this 5 and multiply our empirical formula, the CH2O, by 5. So multiply that by 5. The 5 comes from here. And then that gives us new subscripts of C5H10O5. And so our final molecular formula is going to be C5H10O5 for this particular compound. Number 2 then. We're told that a compound has 58.51% carbon, 7.37% hydrogen, and 34.13% nitrogen by mass. And again, we're asked to find the empirical formula and the molecular formula if the molecular mass is 82.1 grams per mole. So, since we're given percent composition, we will assume that we have 100 grams of our sample, which will give us 58.51 grams of carbon in our sample. We will have 7.37 grams of hydrogen in our sample, and we will have 34.13 grams of nitrogen in our sample. We then again need to find the number of moles in our sample of each of the compounds, and so 1 mole of carbon is 12.01 grams. So that would give us 4.871 moles of carbon. Then for hydrogen, we would have the molar mass of hydrogen is 1.008 grams, which is equal to 7.312 moles. And then finally, we would have the number of moles of nitrogen being 1 mole of nitrogen having the mass of 14.01 grams. We put grams on the bottom and make sure our units cancel out so that we would have the number of moles being 2.436 moles. Again, then we divide through by the mole or the number which is lowest, so that's 2.436, 2.436, and 2.436. And so this is the number of moles of nitrogen, and so that gives us a value of around about 2, a value of 3, and a value of 1 for nitrogen. And so again, these will be our subscripts for our empirical formula. So that our empirical formula, or our simplest atom ratio for this compound, will be C2H3N. And then we can use this empirical formula to find the molecular formula. We can then use our empirical formula C2H3N to find the molecular formula by first finding the molar mass of our empirical formula, which would be, since we have 2 carbons, would be 12.01 times 2 plus 3 times the mass of a hydrogen atom, which is 1.008, plus the mass of the nitrogen atom, which would be 14.01, which would give us a total of 41.05 grams per mole. Then, since we know the molecular mass of our molecule is going to be 82.1 grams per mole, we simply divide this 82.1 by our 41.05 to give us the quotient, which will then be the multiplier for our empirical formula to get our molecular formula. So 82.1 divided by 41.05 is going to be 2. So then we multiply our empirical formula here by 2, and that will give us our molecular formula. So it will be 2 times C2H3N, and that would give us our molecular formula being C4H6N2. And this has a molar mass of 82.1 grams per mole. Okay, let's try our final example. Number 3. A compound contains 16.48 grams of carbon. It contains 1.73 grams of hydrogen, 9.62 grams of nitrogen, and 5.49 grams of oxygen. And we're asked, what is the empirical formula and the molecular formula if the molecular mass is 194.2 grams per mole? So here we're not given the percent composition, but rather the masses of each element that is in the compound. But the approach is the same, and we will need to calculate the number of moles of each element in our compound. So the number of moles will be based on the masses. So we have 16.48 grams of carbon. We have 1.73 grams of hydrogen. We have 9.62 grams of nitrogen, and we have 5.49 grams of oxygen. We then need to find out the number of moles. So the molar mass of carbon is 12.01, which would give us the number of moles as being 1.373 moles. For hydrogen then, the molar mass of hydrogen is 1.008 grams. So that would give us the number of moles being 1.716 moles. Then for nitrogen, the molar mass is 14.01, giving us the number of moles of nitrogen as 0.687 moles. And then the number of moles of oxygen based on the molar mass of oxygen being 16 grams would give us 0.343 moles. Then the approach is the same as before. We simply divide through by the smallest number of moles. So that's for oxygen, so it's 0.343. for carbon, which would give us 4 carbons. Then divide the number of moles of hydrogen as well, so that would give us a ratio of 5 hydrogens for every oxygen. And then for nitrogen as well, we would have 2 nitrogens for every oxygen. And then of course for oxygen, we would have 1 oxygen. So for every 1 oxygen, we will have 4 carbons, 5 hydrogens, 2 nitrogens. So these will be our subscripts in our empirical formula. So our empirical formula will be C4H5N2O. And we can then use this to find our molecular formula. So our empirical formula was C4H5N2O. We're told that our molecular mass of our molecule is 194.2 grams per mole. So as always, we need to find out what the molar mass of our empirical formula is. So it'll be 4 times the mass of carbon, which is 12.01. It'll be plus 5 times the molar mass of hydrogen, which is 1.008, plus 2 times the molar mass of nitrogen, which is 14.01, plus the molar mass of oxygen, which is 16.00. So this will give us a total, if we add this all together, of 97.1 grams per mole. Then, as before, we divide our molar molecular mass of 194.2, so that's going to be our CXHYNZOA formula. So that's going to have 194.2. So we divide that by 97.1, and we find that we have a quotient of 2. So we need to multiply our empirical formula by 2. So we'll have 2 times C4H5N2O, which will be equal to C8H10N4O2, and that will be our final molecular formula. So in this video, we've shown you how to find the empirical and molecular formulas based on percent composition and also based on the masses of the elements in the compound. So now you should be equipped to answer these sorts of questions. Thank you for watching. Bye-bye.